Hello guys, everyone's. Today's discussing. Today's we are going to discuss the new topics, reactive intermediates. The first topics is a completes. Completes it involve the 3 points. First is a hyperconjugations, resonance, and electromagnetic effect, inductive effect. There are 4 points involved in last chapters. These new chapters, reactive intermediate, this is the most important chapters for the organic chemistry because the many reactions intermediate product from the reactive intermediates. The reactive intermediate, it is a very short lived species form in between the reactant and product. This is the reactive intermediate. Reactive intermediate means homolytically and heterolytically bond fusions resulting in the formations of the short-lived species are called the reactive intermediate. The existence of these species, reactive intermediate, can be detected by the spectroscopic methods. Among the reactive intermediates are carbocations, carboanions, and free radicals. These species are reactive intermediates. The first is a carbocation, second is a carboanion, third is a free radicals. These reactive intermediates it involve the homolytically or heterolytically bond fusions. Homo means diatomic molecule. This is the same atoms in a molecules. This is the homolytically bond fusion because the bond break in same atoms. In the same atom is called as the homolytically, and heterolytics means the different atoms breaking the bond between the two atoms of the molecules is called as the heterolytically. Reactive intermediates, the homolytical and heterolytic bond fusions result in the formation of the short-lived species are called reactive intermediate. Reactive intermediate is the most importance of the organic reactions because the reactive intermediate is a short-lived species. For example, the carbocations, carboanion, and free radicals. The reactive intermediates are carbocations. This is the first type, carbocation. Second type is carboanion, and last type is free radicals. The 3 points involved in a reactive intermediates. First, let's see some explain the carbocation. This is the first type of the reactive intermediate. Carbocations means this is the positively charged species. The carbon carry the positively charged. It contains the 6 electrons only in a carbon atoms. This carbon atom is the center atoms. Exactly, carbocations means the organic and this is the organic compound. Organic and contain positively charged carbon atoms, which carbon atom carry the 6 electron in their outermost cells or outermost orbital cells are called as the carbocations. Carbocations means the organic ion containing positively charged. The organic ion containing positively charged carbon atoms. The carbon atom bearing 6 electron in their outermost cells are called as the carbocations. The carbocation in which the carbon center is a sp2 hybridized state. The carbocations in which carbon center is a sp2 hybridized state. The 3 sp2 hybridized states is 1 1 1. Okay, sp2 hybridized state form the sigma bonds with the other 3 atoms. This is the other 3 atoms. This is one atom, this is second and third atoms. This is the hydrogen atoms, maybe other carbon atoms also present here. Here hydrogen, here hydrogen, here hydrogen. Other 3 atoms sp2 hybridized. 3 sp2 hybridized form the sigma bond with other 3 atoms. The vacant p orbital lie perpendicular to the plane of sigma bond. Therefore, the carbocation is a planar structure or planar ion. The vacant p orbitals used for the overlapping of with sigma pair orbital of donate atoms as a nucleophile. This is the vacant p orbital. Incoming nucleophile directly bond formations with the carbocations. Okay, this is the explain of the carbocations. The carbocations of parent alkanes are primary, secondary, tertiary carbocations. The carbocations are classified primary carbocation, secondary carbocation, and tertiary carbocation. There are three carbocations types. Then also another type of carbocation, benzylic carbocations and allylic carbocations. These importance: primary carbocations, secondary carbocations, and tertiary carbocations. Okay, these carbocations are classified primary, secondary, and tertiary carbocations. Only involved in a sp2 hybridized. This is the carbon atoms sp2 hybridized because the electron deficiency create the positively charge, and the carbon having the unhybridized p orbital. This is the empty p orbital. This is the empty p orbital lie perpendicular the plane of sigma bonds. Therefore, the carbocations are planar ions. The vacant p orbitals used for the overlapping with electron pair orbital of donate atoms as a nucleophile. This is the explanation of the carbocations. Carbocations means it is the electrophile center, vacant p orbitals, and form the three other atoms, sigma bonded atoms. This is the carbon center, sigma bond, sigma bond, sigma bond. This is carbon center, sp2 hybridized, and unhybridized p orbitals means vacant p orbitals. The vacant p orbitals, the electrons take electron received from the another donate atom as a nucleophiles. They form the another bonds. Okay, this is the explanation of the carbocation. Carbocations means the carbon center is a positively charged center. It is the sp2 hybridized state, and 3 sp2 hybridized from the sigma bond with other 3 atoms. The vacant p orbital lie perpendicular plane of sigma bonds. Therefore, the carbocations is the planar ions. The vacant p orbitals used for overlapping of electron pair orbital of donate atoms. And carbocations classified are primary, secondary, tertiary carbocation. This is the explanations of the carbocations. Do you got it? Carbocations and reactive intermediate. The carbocation, the method of preparation of carbocations. Let's see against video lectures. Okay, that's all.